Okay, today doing one on amplifier tuning. And since I hadn't put up the little old Browning 100 yet, so I'm going to start with this amp. If it's a CB amp and you're trying to tune and load it, I always say tune for max smoke, but I get questions all the time of where to start at. You know, where you want to start your dials at, or where you want to put it. If it's a CB amp, you want to start halfway. If you can see that little white dot on it, and that one has a little white dot halfway. And you go from there on a CB amp, because most CB manufacturers are going to use parts that are, I guess, conducive for easy tuning for the CB band or the 27 meter band. So, like, the tune cap in CB amps or the 10-11 meter band is usually somewhere around 50 picofarads. And what amp manufacturer do is said, okay, we need 50 more or less, so we're going to put in a 25 to 75 cap for the tune. And the load might be, let's say, 200 picofarads. You see the plates are closer together and it's more plates on the load than the tune. You'll always see it that way. So since they say, well, we need 200 picofarads more or less, we're going to put in a 100 to 300 is what they're going to use. You know, makes sense, right? So a CB amp, if it's unknown where the tunes start in the middle, or you know, straight up going by the dial. I had a couple people ask me, well, how do I know the dial's accurate? Or how do I mark my dial? My knobs might be off. The dial might be off. Well, if it's a cap that doesn't turn around 360, like this one, it's got stops. That's far as it'll go that way, and that's far as it'll go to the right that way, or clockwise, right? So I got it turned all the way counterclockwise to the left, so my marker or dial on the knob should be all the way left, and vice versa. I turn it all the way clockwise where it won't go anymore. It's all the way right on the dial. And some don't even have stops. They'll turn 360, but it's the same principle. If it's fully engaged, it'll be, you know, either fully left or right on the dial. And if it's fully unengaged, because some turn opposite ways as far as the engagement and unengagement of the plates, it would be you know, one fully left, one fully right on the dial, even if it turned to 360. So you need to take off your cover and look at that. Another way is if you turn it about halfway, and it's hard to see from that camera angle, but those are meshed about halfway. When it's halfway, your pointer should be pointing about straight up. And that's how you calibrate your knob or your dial on all these. And it works the same for your tune cap and your load cap. A lot of times the tune cap will spin around 360, not on this one, but the same way. Halfway, you know, should be up, and fully unmeshed should be one way, either left or right, and then fully meshed should be the other. So with that, you start halfway and then you key down and you tune for max quickly, because amps don't like to be ran untuned. The tubes are eating all those watts. Instead of the watts going out, the plate, which would be that big gray part there, that's what, you know, is collecting and trying to spit out those watts. And if the watts aren't going out, they're staying in the tubes, and the tubes are going to be eating those watts, I call it. They're going to suck those watts in instead of going out, and the plates are going to be overheating and getting red. And the quickest way to kill a tube is to untune it, you know, to not tune it to a maximum. So I say always tune it for max smoke or max output. I get a lot of questions on, you know, how big a coil and how many turns, and exactly, you know, I want to know, you know, what kind of wire you use and all that. That's not really the way to do it. That's not even the way the hams do it. What the hams do, they'll look on a chart or a book and they'll say, okay, I'm going to do, you know, 27.2 megahertz, and my I'm running this many volts and this many amps on the tubes, you know, combined, and you can look up the plate conductance of that. And 27 megahertz, some of them even have programs or apps that'll tell you that, let's say you need 50 picofarads on the tune, and you need, let's say, 200 for the plate. And how the hams do it is they will get a cap meter, and they will turn the tune cap to exactly 200 picofarads, or 50 on the tune. I said 50, whatever the book says. And then they'll turn to, 200 or whatever the book says on the plate. And then they'll stick the coil in there, approximately the size that they think they need. And then you can play with the coil, and tune it up. If you got a dip meter or antenna analyzer, you could do it with that. Or if not, you can key down the amp and then, carefully key it down, see what you get, and then you can squeeze the coil, together. You can pull it apart. You can shorter turn, and see if you can get that thing to resonate, because your capacitance says your tune and load are right. So all you got to do is get the coil right. So that's the way the hams even suggest that if you don't know the coil, you start with, smaller amps like this, like 8 turns, and bigger amps 4 turns, and then real big amps about 3 turns is what you start with. But people are like, I want more exact than that. Well, it's not an exact science trying to measure, the coil. So again, they stick them in there. They look it up on an app, or I use this bill or handbook. It's got a page in there that tells you exactly what you should expect as far as the tune cap and the load cap. And I do that, and it's like, okay, your tune should be 25, that should be 200. So I get my cap meter out, and I turn those to 25 and 200 or whatever the book says, and then I stick a coil in there, and then I go from there, and I adjust the coil first. And then once you get the coil where you get it closer, you're getting resonate out of it, you're getting watts out of it, it should be close enough, and then you can go from there and retune your tune and load caps for max output. So that's a way to figure out what you need as a coil. On a ham amplifier, they're going to have a tune cap, especially the tune, that is going to be a much, much, much larger cap. Because on 27 megahertz, you need about 50 picofarads, give or take. That's not exact, but, that's a general of what it's going to use. But as you go down the ham bands in frequency, that 10 should be 28. I don't know why somebody did that. I guess they were thinking 10 meters, but the rest are frequencies. So that would be 28 megahertz, 21 megahertz, 14, 7, 3.5 megahertz, 1.8 megahertz. So anyway, as you go down the frequency or up the ham bands, you're going to need more and more tune capacitance. It about doubles when you half the frequency. So at 28 megahertz, you need about 50, which would be the 10 meter band. And then if you go to 14, you need about 100 picofarads. If you go down to 7, you need about 200. And then, 3.5, 400 picofarads instead of, the 50 you start with. So with the ham amplifiers, you're going to see usually a big tune cap. And it's the same idea with the load, but the load cap gets so big that it gets unfeasible to have like let's say a 2000 picofarad load cap that you need for the ham band. So what they do is they switch in extra capacitance. So let's say you needed 2000 picofarads for the load, let's say 3.5 megahertz out. So what they would do, they would stick in a 500 picofarad cap, and then they would add 2,000 more picofarads of fixed caps. And you can kind of see it right here in this, what is this? Meritron AL82 here. That cap there is the big tune cap, because you got to cover all the bands, and it doesn't switch in any extra picofarads on the tune. And let's go over here to the front of this thing. plate tune there at the top, and it's got the ham bands in it, you know, for 15 meters. It would, you know, be very little capacitance. You know, it doesn't have 10 mark, but you're almost at a minimum. And then as you go down to the other meters, you can see there, you know, you're going to need more and more capacitance, right? But what they do for the load, when you turn the band switch, it actually switches in. Like some of them capacitors there are fixed, and some of them there, and you're switching in more and more coils to make it tunable or feasible to use all that. But CB amps don't have that. They're not going to use a great big, you know, 300, 400 picofarad cap for the tune, because it don't need it, right? They're going to use basically what you need. So a CB amp, you start in the middle, and a ham amp with all the ham bands in it, you're going to start almost at minimum on the tune cap. And these are marked here. Well, no, this one is marked. You know, you got the 21 megahertz, and then for 27, which this one is already tuned for, it's a little bit below the 21, almost at it, but almost at a minimum on the tune. The load's a different animal because you still need about 400 picofarads for the load, and like I say, they switch in extra capacitance for the load as you go down the band. So if I'm going to tune up a ham band amp, if it's marked like this one, I'm going to put it, you know, where it's supposed to be. If I'm doing 27, 28 megahertz, I'm going to tune it, you know, below the 21, somewhere in there where this one is pointed to. And if I don't know what the load is, I might start in the middle or a little bit less than the middle, which, you know, this one is loaded up, so it's at, you know, close to the middle. Same with this alpha here. You know, it's not marked, but it is marked, you know, like minimum and maximum. And this one was tuned up, you know, last time I used it for 10 meters, 28 megahertz. And it's near the minimum, you know, same principle. You're going to need all that extra for the other ham bands. And then the load, almost in the middle, right? And the Meritron is marked. Sorry about my camera work. Tune at a minimum mesh. And then the load almost, not quite to the middle, but, you know, pretty much in the middle. One thing I wanted to say about if you're, you know, winding your own or messing with your own coils and amps and all that is, if you got an amp where one of the caps or both of them, the tune and the load, are tuning at either a minimum, which would be that, and it won't go nowhere. It's tuning right there. And it looks like, you know, it should go further, but it ain't. If it's tuning there, or if it's tuning with at the maximum capacitance all the way in, then you need to mess with your coil, your tank coil there, right? But if it's tuning there, that's maximum capacitance, and you want it to tune with a little bit less capacitance, so it, you know, it'll resonate better. You want it to tune less capacitance with your coil. More coil make it tune less capacitance, right? It's the opposite of, you know, more is more and less is less. So more coil. So if we squeeze this together there to make it more inductance or more coil, it would tune with less capacitance. So instead of here, you know, maybe we would want it to get it to tune here. So you never want your tune and load caps to be tuned at either other edge. If it was tuning there, and same with the tune cap, you know, at minimum capacitance, since we want it to tune with more capacitance, we would want less coil. So we would spread that coil out some. And whatever you do, don't be touching stuff, you know, if you got it plugged in and it's on and you're not sure it's drained, like I'm doing now. This amp, it's unplugged, hasn't been plugged in since, you know, 2 days ago. It's got bleeders in it. There's no voltage in it. So don't kill yourself. By the way, if you're going to use a meter on an amp, sweep tube amps like these little small glass tubes here run about 700, 800, 900 volts. So if you get a 1,000 volt voltmeter, you can actually measure the volts. But transmitting tubes start about 2,000 volts and up, 2,000, 3,000. I think this little Clipperton with 572Bs runs about 2,700. And I'm actually gonna fire it up right quick. Oh, and the reason I dug out this Clipperton is I had somebody ask me, they're playing with mono banding one, and they're like, where does theirs tune up at? Or where does mine tune up at? Where should it? Again, it should tune up under that 21, somewhere under, but not a minimum. And this is where mine tunes up at, with the original capacitors in it. And I don't think this one has been mono banded. I don't think. Let's see something. No, sounds like we got a band switch in there. So if it is mono banded, that band switch at least is still in there. And this thing is running at about 2,600 volts. So hey, don't stick your hands in that. That will kill you, right? Yeah, I don't want nobody dying on my Accord. But the reason I did fire this up though is you can tell a lot from an amp if it's got meters in it. This one has a voltmeter, VP, plate volts, and a current meter, plate current, right? And that's all it's got on it. But you turn it on, the volts are going. I know my high voltage is good. At least I got 2,700 volts on the meter. And this runs on a foot sweater pedal, so I'm going to key it down without any drive, right? And the voltage should drop a little bit. I'm in transmit mode. You see the voltage drop just a little bit because there ain't no drive, so it's nothing pulling on those volts right there with no drive in it. It's just this, the ground is engaging and everything's engaging, and it's running a little bit of plate current, and it's dropping the voltage a little bit, but not much. And last, I'm just going to key it down and put some drive to it. That's to show that the voltmeter is going to drop a lot, right? Audio. See how it dropped from about 25 to about 23? That's about the normal operating output voltage. It's pulling current and putting out watts now, and the voltage meter is dropping some. So that's telling me that, all that is right, pretty much. That I'm getting drive, my volts is right, and it's pulling amps because it's dropping all from that voltmeter. You can do the same with the current meter. You can't tell if you got volts or not because it's at zero when you're not keyed down and no drive to it. But that's telling me, well, it's behaving. I'm just going to key down the foot switch again with no drive. I get a little bit of current. And that's what you get on these amps. If you know how to use your meter, you get a little bit of current when you key down with no drive. And then I'm going to key down the mic now and put some drive to it. And there goes my current, in operating area, operating range, right? Now I'm pulling, 0.4, 0.5 amps, about 2,200 volts. The thing is pulling over 1,000 watts right now. And here's the watt meter. I'm dead keying 400. Audio. Talking about 8. Driving it with this little JB 200 back down to about 100 watts. That's all I'm putting into it. And last, I'm going to put it on peak. Audio. Doing about 1,200 peak on this thing, right? There goes my current meter. And you can see the voltmeter drop. Audio. And that's the normal stuff you want to see just by using the meters on it. If something is not doing what I just showed you, like if I key down, just the foot pedal, that's not dropping something's wrong. If I key down the drive and it doesn't drop a lot more like that, that means the drive is not making it into this, into the circuit of the amplifier. And same with the current. Key down the foot switch, if I don't get a little bit of current jump, something's wrong. And I don't have to worry about the drive. It's something in the voltage circuit or the bias circuit or the ground circuit. If I key down just the foot switch going to transmit, I don't get a little bit of current. And then when I hit the drive, if it doesn't go up like that, even if it's not showing any output, I still should be reading current if the thing is getting drive. So I know I'm getting drive just by the amount of current, even if it wasn't showing any output. And if an amp, now a lot of amps don't, especially CV amps, if it's got a grid meter, the grid is actually the drive. So This one's not hooked up, not going to run the alpha, but because this one got the high voltage meter. Well, the multimeter shows high voltage and grid and power out, and then it's got a dedicated current meter that shows current all the time. But it's the same principle. And if you put it on grid and you're driving it, that grid meter ought to be going. If the grid meter is not going, then that means I'm not getting any drive. Something's wrong with it. So you can tell a lot just by looking at the metering of the amp. And if you're working on a smaller squeak tube amp that's got no meters, you can't really measure the high voltage, but you can get an amp meter, like a plug-in amp meter like this one here, which is not connected to, because I think I got that on 220, and this one's 110 only. But if you're working on a smaller amp, 110, and it doesn't have any meters, you can at least use the amp meter on that. You turn it on, the tube's lighting up, the fan's blowing, it's going to be pulling an amp or two. You key it down, and if it's pulling and it's getting dry, those amps ought to go up a lot. And you can tell it, well, if the amp's going up, I'm getting drive at least, even if I'm not getting any output. So you know where to look at just by looking at your meter. And you can look at other things, like if your tubes are getting really hot when you key down and you ain't got no output. If the tube's getting hot like that, you got voltages and you got drive and all that, because that's what's making the tubes get hot. But you can work on your output side. If the tubes ain't getting hot, not pulling current, well, maybe it's the drive, maybe it's the high voltage, but you don't have to look at the output side, because tubes ain't getting hot. So some reason they not pulling, you're probably not getting drive, or you don't have high voltage to the tubes. But anyway, that's going to be my thoughts on this one. Just trying to keep it simple, so I don't want to hear stuff like overcoupling and all that right now. Just trying to keep it simple. That's it for class session number 2. Hope it helps. Bye.